Show that if A is invertible, then the determinant of A inverse is equal to 1 by the determinant of A. So let's look at the proof here. So we want to begin by supposing that matrix A is an n by n invertible matrix. So if A is an n by n invertible matrix, we know that by definition, this implies that the determinant of matrix A does not equal 0. And we can also conclude that matrix A right-hand multiplied by the inverse of A is equal to the n by n identity matrix, as well as a left-hand multiplied by A inverse is also equal to the n by n identity matrix. So we can further observe that since A is invertible, by the properties of invertible matrices, so since A is invertible by the properties of invertible matrices, we can also recall that A inverse is invertible. And since A inverse is invertible, this implies that the determinant of A inverse is not equal to 0. So keeping these two definitions here in mind, these two properties of invertible matrices, we can now go ahead and apply the multiplicative property of matrices and the determinant. So by the multiplicative property of determinants, we can make the following conclusions. So we note that the determinant of matrix A multiplied by the determinant of the inverse of matrix A is equal to the determinant of matrix A multiplied by the inverse of matrix A. And looking at the argument of the determinant on our right-hand side, we know that since A and A inverse are both invertible, that their product is the identity matrix. So the determinant of the identity matrix is simply going to 1. So we are now ready to go ahead and solve this algebraically. So simply by dividing both sides by the determinant of A here, we are left with the determinant of A inverse is equal to 1 divided by the determinant of A.